Okay. So, we are talking about how we can construct the DFA from NFA, the equivalency between the DFA and NFA. That means, given a NFA, how we can get a corresponding DFA, which is accepting the same language. So, this is a NFA. So, this is the language of this NFA is this. Now, from here we have to construct a DFA D. So, this is NFA. So, these are the state for the NFA. So, we have to construct a DFA. So, QD, so sigma is same, the input alphabets is same for both the cases, but rules will be different, Q0 and FD. So, this is the DFA such that the language of the DFA will be same as language of the NFA. So, this is our goal. So, in the last class we have seen some way to construct that is the subset construction method. Okay. So, how can do that? So, basically we have to take the given NFA, we have to take the all the DFA Q is nothing but set of all possible states, subset of this QD is 2 to the power. So, this is the power set of this. So, this is the set of all possible subset of the states in NFA. So, this is huge number. If there are n state in the NFA, if q n is equal to n, then q d will be the cardinality of this set. This is 2 to the power n. But we do not really need to consider all the states. We will take the states which are accessible from Q. So, we consider all the subsets which are containing the Q 0. So, which are accessible from Q 0, the starting state, because we are talking about in terms of the language. So, language means we start from a starting state and we should able to reach to the final state. So, that is the string accepted by that automata. So, since we are talking in terms of the language or string accepted by the automata, so we will only consider those states in the QD, those subsets which is containing Q 0. That means, those are which are accessible from Q 0, only those set will be considered. So, for example, so if you take the example from the last class, so suppose we have given this NFA. This is the starting state or the initial state, and we have these are the states, and we have a final state which is D. So, and this is 0 1. So, this is NFA. So, we can have non-deterministic move 0 1 0 1. Okay. Now, we have to consider this is the NFA N. Now, we have to consider equivalence DFA D Q. So, Q D sigma will be same for both the cases, and the rule starting state and the FD. Okay. So, FD so this we will do using the subset construction method. So, here we just consider the states, the states, these are the states that can, these are the all subsets. So, we do not need to consider all the subset, we consider only those subset state which are that are reachable. See, reachable from the starting state q 0. That is the subset of this which contain q 0, subset of this q n, this is the q n. So, q n is nothing but a b c d. So, the subset of q n that contain all the subset of q n that contains containing the starting state. The starting state here A. So, that containing A. So, who are the so A, these are the possible state of this DFA. So, these are the QD A, AB, then AC, then ABC, then ACD, ACD. So, these are the possible, these are the all possible subset of q n which are containing A. So, and these are the set subset which are reachable from A. So, among these, since this is the final state, so these two are the, so these are our, this set is our q d. So, this we can refer as x 1, x 2, x 3 like this. So, there are 5 states in the new DFA, and among these two are the final state, because these are containing, sorry, this is the AB, AC, AB, oh, ABD, because C, AC, ABD is the state which is reachable from A. So, we consider only those subsets which are reachable from A. Okay. So, this is the state. So, now let us construct the, and these two are the final state, because these two contain the final state of q n. So, now let us consider the construct the this rules, transition rule for the DFA. Okay. Now, let us consider the transition rule. So, we are constructing delta D. So, we are constructing a Q, I mean this is our Q D. So, this is the DFA we are constructing, Q D is A, then A B, and A is the starting state, then A C. So, these are the subset which are reachable from A under that rule. Okay. And these two is the, because these two are containing the D, D is the final state of the automata. So, these two are the final state of the DFA also. Okay. Now, the rule. So, if we have a 0 1, so 0 1. So, if we have 0, so 0 we can go to where? So, 0 means we can go to B or we can go to A. So, this is going to A B. So, rules are same, basically delta of D, so we are considering a subset, that subset is S comma A is nothing but this is delta n of P comma A. So, P is belongs to S. So, this is the way we construct this. So, that means, so delta of A, here we have only one set. So, delta of A is basically the from A where we are going by the 0 move. So, we are going to B and A. So, A B. Now, with 1 from A where we are going, we can go to A or we can go to C. So, this is the AC. Okay. Now, from AB, so from AB with the 0 move, we can go to, from A we can go to AB, and from B we can go to D. So, if you take the union by this rule, by this formula, if you take the union, it is A B D. A B D. And then similarly from AC from A B with the one move, from A we can go to AC, and from B there is no move from with the one move. So, from B delta n of B comma 1, this is empty. So, empty along with AC is AC. Now, from AC if we take the 0 move, from A if we take the 0 move we are going to AB, and from C if we take the 0 move there is nothing. So, this is going to AB. Okay, now, from 1, I mean with the 1 input. So, from A with 1 we are going to C and AC, and with A from C we are going to D. So, this is basically AC ACD. Okay. Now, come here ABC. From ABC with 0 move from A we can go to B or B and A, AB, and from B for 0 move we can go to D, and from D we can go to D. So, this is basically ABD. So, we are using this formula to get this. Similarly, this will be ACD, and this will be again ABD, and this will be again ACD. So, this is the corresponding DFA, rules of the transition rule of the corresponding DFA. So, if you construct this DFA, it will be like this. So, you have 5 states. So, you can rename this say this is A, then we have AB, then we have AC, then we have 2 more steps ABD and ACD, ABD and ACD. So, these are the states, and then we have the rule. So, from A, this is the starting state. From A we go to with the 0 move we go here, with 1 move we go here 0 1, and from AB with the 0 move we go here, with the 1 move we go AC, and from AC we go AB with the 0 move, and we go to ACD with the 1 move. And from ABD, if we take a 0 move, we will hop here, and if we take a 1 move, we will go to ACD. And from ACD, if we take a 0 move, we go here, and with 1 move, we go here. So, this is the corresponding DFA rules. Okay. We can just rename these as other symbol like P, Q, R, S, T. So, these are just a notation. So, okay. So, this is the equivalence DFA, and both these are accepting the same language, and the language is the ending with the 0 0 or 1 1. So, any string ending with 0 0, I mean any string containing 0 0 x y. So, x y r belongs to, this is one option, and like it is in the regular expression is called 0 0 star plus 1 1 star. We will discuss this when we talk about regular expression. This is the union of two languages. This is one language which is having the 0 0 as a substring, and this is another language which is having 1 1 as a substring. So, this is the, and the final states are these two. this and this. Okay. So, yeah, so this is the equivalence DFA, and we can just, as I said, I can just rename this DFA like this. So, W R S T U. So, this is 0 move, this is the starting, this is 1 move, this is 1 move, this is 0 move, this is 0 move, this is 1 move, so this is 0 move, and this is 1 move, this should be 0 move, yeah, this is 0 move, sorry, this is 0 move, and this is 1 move. So, this is the corresponding DFA of that NFA, and these two are accepting the same language. We will prove that. So, let us take another example. One more example, then we go to the result that these two are accepting the same language. Okay, let us take another one. So, we have q 0, this is the start, and q 1, q 2. So, we have 0, 1, 0, and this is the final state, and here we have 0 or 1. So, this is NFA, simple NFA. So, what is the language accepting it? So, it is accepting like 0, 1, 0, 1 or 0, 0 or yeah, we can have. So, the string containing the end of this string containing 0, 1 or 0, 0. So, this is basically, this is the way we write in regular expression. Okay. So, the string containing 0, 1 or 1, 0. So, any this of. Okay. So, now we want to have a corresponding DFA. So, as you said, there are 3 states. Now, the DFA state will be all the possible subset, but among these we consider only those subset will containing the this starting state, that q 0. So, who are they? They are basically q 0. So, q 0, then q 0 q 1, then q 0 q 2, and then we have q 0 q 1 q 2. So, this is our N, this is our q d. Okay. Now, regarding the rules, so we can just write this states. So, this is the delta d we are getting. So, this is q 0, which is the starting state, and we have all the other state q 0 q 1 and q 0 q 2, sorry, q 0 q 2, and we have q 0 q 1 q 2, and among this which are the final state. So, these two contain q 2, which is the final state. So, these are the 2 final states for the corresponding DFA. Okay, now, we put a 0, we put a 1. Now, the rule is same that that q b of, because this is a subset s comma a is nothing but union of sorry, delta d of s comma s p a, where p is in s. Okay, so, from q 0, where we can go with the 0 move, from q 0 we can go to q 1 and q0. So, this is going to q0 q1, and with 1 we can only go to sorry, this is 1, made a mistake over here. If this is 1, then this is accepting the string 0 1 1 or 1 0. Sorry, this is 1. Yeah, this is 1. Anyway, so this is q, then it will be for 0, it is only q0. Okay, and with 1 it is q0 q1, because with 1 we have two options. Now, q0 q1, with q0 0 we have q0, and on q1 we have q2. So, this is basically q0 q2, and similarly here with q0 1 this is the case, and with q1 1 q2. So, this is q0 q1 q2 by this union rule, and from q0 q2, q2 there is nothing. So, from q0 if it is 1 we are going to q0 only, sorry 0 we are going to q0 only, and from q0 q2 with one move, from q2 there is no move, that is the empty set, union with empty set is the same. So, with the q0 with 1 we have q0 q1, and with this we have, so we have q0 q2, and then we have with 1 what we have, from q0 with 1 we have q0 q1, and q1 with 1 is q2, and q2 with 1 is nothing. So, this is basically q0 q1 q2. So, this is the rule. Now, if you draw the picture, it will be like this. So, this is q0, we have q0 q1, then we have q0 q2, and we have q0 q1 q2. These are the states, and from q0 we are with the 0 move we are here, with 1 move we are going here, and from this one q0 q1 with 0 move we are going here, and with 1 move we are going here. So, this is 0 move, this is 1 move, and from q0 q2 with 0 move we are coming back here, and with 1 move we are going here, and from q0 q1 q2 with 0 move we are going here, and with 1 move we are here, and these are the, what are the final state? Final state are basically the subset with containing q2. So, these two are the final sets. So, this is the corresponding DFA from this given NFA. So, this way we will construct the DFA. Now, we will have a theorem to show that. So, this is the NFA and this is the DFA. Now, the language of this NFA is same as language of this DFA. So, this we have to formally prove this. Okay, so, this just we take a theorem over here. If D is the corresponding DFA, delta D q0 ft is the DFA constructed subset construction, constructed from the NFA Qn sigma delta n q0 Fn. this is the given NFA. From this given NFA, we are constructing DFA by the subset construction method. Then the language of this NFA is same as language of the DFA. So, that is the goal. I mean, given a NFA, we can have a equivalence DFA. So, that because we know that DFA NFA is easy to construct. If you have a language which is regular language, so from a given language we can easily construct a NFA than DFA. So, once we have a NFA, then we can construct the DFA. So, how to prove that? So, prove that we have to use a result which is on the extended transition rules. Delta D of Q 0 W is same as delta N of Q 0 W for all. So, this is the this we can prove by induction. So, what is the meaning of this? Meaning of this is so we start with Q 0. Now, we have constructed the DFA. So, we start with Q 0, we read a W, this is a string and it will end up to a subset. This is the DFA move, and the way the DFA is constructed, this is same as in the NFA. We start with Q 0, we will reach to this. So, with this W, we will reach to those sets. So, this is a subset also. These two sets are same, and this is true for every W, because for W is equal to epsilon, this is true because we will be remain at Q 0. But for W is not equal to epsilon, we have the inductive proof of that. So, this will give us the conclusion that they are accepting the same language, because this needs a proof, but this proof is not tough. This is the inductive proof is there. So, if we assume this is okay, then the DFA accepts a string if and only if delta D of Q 0 and W is belongs to FD, and FD is what? FD is the FD contain one of this final state of Q. So, that is delta hat of Q 0 W intersection F n is not null. So, this implies delta hat of n Q 0 W intersection F n is not null. So, that means if it is, if a string is accepted by this DFA, then that same string will be accepted by this NFA, because the way we have constructed FD. So, FD is the accepted state of DFA. So, it is the set of all subsets such that, so it is containing all subset of this Q n, sorry. So, it is containing all the subset of Q n such that the FD and Fn are not null. So, at least it should have one final state. So, that means, if it is reaching to a final state, that means the same rule will give us to the final state by the NFA. That is the way we have constructed by the subset sum. So, this is the equivalency. So, if a language is accepted by a DFA, then the same language will be accepted. If a string is accepted by a DFA, the same string will be accepted by the corresponding NFA. So, this is the equivalence. So, to show a language is regular or not, we just need to have a NFA which is accepting that, because we know once we have a NFA we can have corresponding DFA which is accepting that same language. So, we will talk about more in details. Thank you.